Oh, welcome and thank you for joining. Let's take a look at another interesting limit. This time we have the limit as x approaches 64 of the third root of x minus 4 divided by the square root or the second root of x minus 8. Now, as you can see, by direct substitution, we'll obtain the third root of 64, which equals 4, minus 4, that would be equal to 0. And then in the denominator, we'll have the square root of 64, which is 8, minus 8 would equal 0. So as you can see, this is an indeterminate form limit, which means we cannot evaluate it by direct substitution. And another thing we notice, or another thing we actually get from the direct substitution here, is understand that at x equals 64, the numerator will be 0. So that will make x minus 64 a factor to the numerator based on the factor and remainder theorem. Similarly, denominator will be 0 at 64, which means x minus 64 will be a factor to the denominator as well. So in order to evaluate or estimate this limit, then we have to bring x minus 64 into both numerator and denominator. And the way we want to do this is by first recognizing where 64 is hiding in all these terms. So first, we are going to rewrite this limit slightly differently. And the first step to actually trying to bring x minus 64 in numerator and denominator is by rewriting each term with similar numbers. So what that means is that instead of writing cubic root of x, we're going to write x. And then instead of the radicals, we'll have to use powers. Now we know that radicals convert or translate to rational powers. Similarly, for x in the square root of x in the denominator, we'll write x to the power of 1 over 2. So at least we know that we are dealing with exponential numbers of the same base. Now, for number 4, because our goal is to connect these numbers with 64, instead of writing 4, we're going to write the cubic root of 64, or even better, 64 to the power of 1 over 3, which is equivalent to 4. And for number 8, we're going to write it in terms of 64 as 64 to the power of 1 over 2. Now, as you can see, in both numerator and denominator, we're using the same basis for each term, which will make us, which will make it hopefully easier for us to connect these numbers in such a way that we can bring x minus 64 in the numerator and both denominators, so in both of them. Now, we're going to examine separately the numerator and denominator. As you can see, in the numerator, we have x and 64, and both terms will have a power of 1/3. So we've done this before in other questions, and you probably recognize or remember the strategy we used. So whenever we have powers of 1 over 3, to make x minus 64, we will wish to have no powers in here, or in other words, to have a power of 1. So which means that to bring x minus 64 here, we're going to need to have each term to the power of 3. Now, I want you to think what can make this entire numerator have x to the power 1 over 3 power 3 and 64 power 1 over 3 to the power of 3. So in order to have x minus 64, or this term power 3 minus this term power 3, we'll have to multiply by the other factor that will bring the difference of cubes here. Remember, the difference of cubes formula suggests that if we have a minus b multiplied by a squared plus ab plus b squared would equal a cubed minus b cubed. So what we want to obtain in here is a cubed minus b cubed, which means that we need to multiply this factor by this one here in order to get to a cubed minus b cubed. Let me make the number 3 a little bit look better there. Okay, so here we go. We have this portion of the factored form, so the a minus b portion. we need to multiply this by this factor in order to bring a cube minus b cube or x minus 64 there. So we are multiplying by, I'm going to open up square brackets here. So we have x to the power of 1 over 3 squared plus x to the power of 1 over 3, 64 to the power of 1 over 3, and then plus 64 to the power of 1 over 3 squared. Close the square brackets. And since we're multiplying the numerator by this factor, then we're changing the value of the expression, which we're not allowed to. So we are going to multiply by the exact same thing, the denominator as well. So to maintain the value of the expression. Oops, sorry. So let me just copy this. It's faster this way. All right. Here we go. So both numerator and denominator will be multiplied by the same expression, which means it's a multiplication by 1, which doesn't change the value of the expression. Now, similarly, what we have in the denominator is x to the power 1 over 2 minus 64 power 1 over 2. And what we want to obtain is exactly x minus 64, which means that we want this term here to be squared and this term to be squared in order to have x minus 64. Now, what can bring something squared minus something squared here, or the difference of squares? So, again, recall the formula that states that a minus b times a plus b would be equal to a squared minus b squared. So we are trying to bring this to the power of 2 and this power of 2. So we are trying to create this while we have this part of the expression. So that means we have to multiply by the conjugate, which will be the exact same terms with a plus in between. So we'll do the same thing to both numerator and denominator. So we're multiplying by x to the power of 1 over 2 plus 64 to the power of 1 over 2, both numerator and denominator. So this is sort of a double conjugation. And it's not like the double conjugations we've done before, where we have dealt mainly with square roots. It involves the cubic roots. So now let's start simplifying. Let's see what we obtain here. So we have the limit as x approaches 64. Now remember that our interest is in bringing x minus 64, which will come in the numerator if we multiply these two conjugates. So by the multiplication of them, then we'll get x to the power of 1 over 3 cubed minus 64 to the power of 1 over 3 cubed. Now, obviously, we still have more terms to add to this numerator. So we have the factor of x to the power of 1 over 2 plus 64 to the power of 1 over 2. We'll keep the difference of cubes that we created here in brackets because it is more than one term and we have multiplication. And in the denominator, we will multiply x to the power 1 over 2 minus 64 power 1 over 2 by x to the power 1 over 2, 64 plus 64 power 1 over 2. That will give the difference of squares. So x to the power 1 over 2 squared minus 64 to the power 1 over 2 squared. We'll keep this in brackets because it's in binomial form. And it will get ready to multiply the other factor, so which was the conjugate of the numerator. Now, let's take a look at what the simplified expression would look like. So we have to simplify within each factor. So notice how the 3 and the 3 here will divide to 1. That would leave x to the power of 1. And then similarly, 3 and 3 will simplify or divide to 1, which will give 64. So x minus 64 is one of the factors. And in the denominator, we'll have, again, x to the power 1 over 2 squared, so that's x. And then 64 to the power 1 over 2 squared is 64. So x minus 64 is a factor to both numerator and denominator. And we still have the other leftover conjugates here. We have x to the power 1 over 2 plus 64 power 1 over 2 in the numerator, and this entire conjugate of the difference of cubes in the denominator. So finally, we have x minus 64, a common factor to both numerator and denominator. We'll happily simplify them, and we will rewrite this limit in the most simplified form possible. So x is approaching 64, and long fraction line one more time, and denominator still has this amazing conjugate sitting here. We no longer need the brackets. There is no harm in keeping the brackets on, but we don't need them. And the numerator will have x to the power of 1 over 2 plus 64 to the power of 1 over 2. And now let's see if we are ready to evaluate this limit. So instead of x, we're replacing it now by 64. So we have 64 to the power 1 over 2 plus 64 power 1 over 2. And in the denominator, we'll have 64 to the power of 1 over 3 squared. That would be 64 to the power of 2 over 3. I will leave it as is. It's kind of easier to mentally estimate it this way. So plus 64 to the power of 1 over 3, 64 power 1 over 3, and then plus 64 power 1 over 3 squared. So 64 power 1 over 2 means the square root of 64, which is 8, plus 8. Denominator will be, and this is kind of easy because we end up with the same terms. This is the third root of 64. Third root of 64 is 4. So this would be a 4. You square it, 16. And then plus. Now, the third root of 64 is 4. So we have 4 times 4, so that's another 16. And then we have the third root of 64 of 4, square it, again, another 16, and add all the numbers in the numerator. There is only two numbers, 8 plus 8, 16. And the denominator will have 16 plus 16 plus 16, which is 48. And 16 divided by 48 is 1 over 3. And that would be the limit of this function as x approaches 64. So if you'd like to check and see if your answer is correct, always use Desmos. And let's take a look at it together. So we had y equals the third root of x. So I'm going to bring x to the power of 1 over 3. And then we had minus 4, right? And that will be divided by, okay. I'll keep this in brackets so it's easier to perform the division. So divide by the square root of x, and then minus 8, we said, right? So this would be the graph of this function. Sorry, we should have gotten out of the root here. Okay, so let's take a look at the graph of this function at 64. So we have to get all the way down here. So as we get closer, so let's see what is happening exactly at 64. So first you want to guess what is going on at 64. So are you going to see a solid line here, or do we see a break? So obviously at 64, exactly 64, the function is undefined, but you see that the limit of the function, or the value of the function, is approaching number 1 over 3. And you can tell because as you get closer to either right or left side of 64, you see that the y value is 0.333, which is the decimal value of the fraction 1 over 3. So I hope this made sense, and I hope this helps you solve other limits that involve radicals of higher index or of a different index. Bye for now, and thank you for watching.